All right, number 1 says you have a square. So draw a square if you didn't. And it says the area is 102. If I'm writing, you are writing. Which measurement is closest to the side length? Well, you know that the area of a square is found by multiplying side times side. That means side squared. So the opposite of that is not to divide, it is to square root. Make sense? So you simply take that and square root it. That's all you have to do. So the square root, and let's refresh in our calculator, the square root button is found right here in blue. So second square root of 102, and that's your answer. So it's found between, or which one is it closest to? 10. The second question was the exact same. Tammy completely covered a square wall, so draw a square with an area of 55. If I am writing, you are writing. Which measurement is closest to the side length? So you take that number and square root it. That's all you're doing. And the answer was 7.4. So the closest was 7. All right, this question has been found repetitively on the STAR test. It is a super easy question. All you had to do was read. Which point best reflects the value of the square root of 3? Well, I don't know what the square root of 3 is, so what should I do? Put it in my calculator. The square root of 3 is, I don't see everybody looking with me and participating, $1.73. If I write it, you write it. All right, so which one of these answers, there's just no way it could be that? D. How much money is D? All right, so D's got to go. What other answer there's no way it could be at? On 1, A, because that is just $1 like with no change. So now all we have to do is decide between B and C. Let's talk about B. B is perfectly halfway between $1 and $2. How much money would that be? $1.50. So B is out. C is a little bit more than $1.50, but less than $2, which could be easily $1.73. How'd y'all do on that one? Pretty good? All right, number 4. When 3 squares are joined together to form a right triangle, the combined areas of the 2 smaller squares is the same area as the largest. It's saying this plus this has to equal this. Do these 3 squares form a right triangle? This is the lesson you learned on Thursday or Friday, converse Pythagorean theorem. All you had to do was see if it was true. Now, this question was also on your assignment. Do you see how this one says centimeters and this one says centimeters? I don't see everybody looking. But what does this one say? That means this one is already squared, and these are not. So all you're doing is checking to see, is a squared plus b squared equal to c squared, yes or no? Okay, do I need to square this one? Yes, so because it doesn't have that little squared right there, so I say is 6 squared plus, does this one need to be squared? Yes, 8 squared. Is that equal to, does this one need to be squared? No. And all I got to do is check that in my calculator. Did it work? Yes, 100 does equal 100. So the answer was yes. I'm going to say it again. If it doesn't have a squared on it, you have to square it. But if it already has it, it means it's already done. It's saying that that is the area of this square. Okay? All right, next question, number 5. I don't see everybody looking. Do these 3 squares form a right triangle, yes or no? Okay, well, let's look. Which one's the biggest square? This one, right? Okay, so that one has to be the C. Stop and look. Does this one have a squared on it? So what do I have to do? I got to square it. Is 5 squared plus, does this one have a squared on it? Yes, so do I square that one? No, plus 49 equal. Does this one have a squared on it? Yes, so I don't square it. So I say, is 5 squared plus 49 equal to 100? Does 74 equal 100? No. So the answer was no. All right, before we even read all this information, let's just look at this. Is this a right triangle? So we know that the two smaller squares do what? This square plus this square has to equal? So I would say N plus L has to equal what? All right, so we're looking for something that says that. The sum of N and L is equal to K. Yes or no? What does sum mean? Okay, so if I add N and L, would it equal K? There's your answer. The two smaller squares add up to equal the bigger one, and add means sum. All right, this is a question you have seen repetitively, so I want to make sure I explain it really, really well for those of you who still don't understand. Does everybody see that this right here is what type of shape? What kind of triangle? I don't see everybody paying attention. Okay? Do y'all agree that that right triangle stops right here? And this 8 is not part of that picture. Do y'all agree? So, do I need the 8 right now? No. So, I know that this side must be side what? This has to be side C. So, I'm going to call this side A and this side B. And I don't even want to look at this because it has nothing to do with the right triangle. Do y'all agree? So, I'm just going to keep it covered so that I don't get confused. I'm going to write my formula. A squared plus B squared equals C squared. Am I solving for C where I add, or am I solving for A or B where I subtract? I'm going to subtract, okay? So I have 7 squared plus B squared equals 25 squared. And I'm going to subtract, and I think a lot of you have learned the shortcut where you just do the square root of 25 squared minus 7 squared. Have y'all all learned that shortcut? And that is this number right here. From here all the way up to the top of the triangle, that is 24. But that's not my answer. And we're going to talk about why. So everybody agrees from here to here it's 24, yes? But the question says, what is the total height of the building? They're wanting this number from here all the way up to here. Well, we know this is 24, and what do we know this is? So what would I do with those two numbers? Just add them together. 24 plus 8 is 32. And that would be my answer. That's why I needed that 8 right there, because they were adding that back into my final answer. How do y'all feel about that question? Good or no? Do I need to explain it better? Are we okay? All right, moving on. All right, where's my right angle? Right here. What is this side called? C. They want to know what is the length of the ramp. That's the C. So I write A squared plus B squared equals C squared. This is going to be A. This is going to be B. Do I add or subtract? So I have 11 squared plus 60 squared equals c squared. Do y'all like adding and then square rooting, or like it all in one step? All in one step? Does everybody agree or no? So if you want to just add, you would do 11 squared plus 60 squared. And then you would, oops, I didn't mean to do that. 11 squared plus 60 squared. You would take that answer and do what to it? Square root it. So I go like this. Or if you want to skip doing those, you could do the square root of 11 squared plus 60 squared. And you'll see no matter what, you're going to get the same answer. That's just a skipping of a step. Okay, so my side C is 61. Number 9, everybody find the right angle. Draw a line across from it. This side has to be side C. So we'll call this A and this B. I don't see you writing. If I'm writing, you're writing. So I write my formula. Am I going to add or subtract? Subtract. So again, I could just do the square root of 89 squared minus 80 squared. If you don't want to go write all that, then all you're going to do is subtract. The square root of 89 squared minus 80 squared, and the answer is 39. If you wanted to write it all out, that's perfectly fine. All right. Do I need to slow down? Everybody okay? The next one. This one, do you have to go draw it? You could, but when they're telling you that you're translating it, this is your side links. Do y'all agree? Yes or no? So if I just, I'm going to show y'all without this graph. If I put a dot T right here, and I go 4 units to the right, it's going to look like that. And then 6 units down, y'all agree it's going to look like that, and it's going to be a right triangle. Or I could go graph it and put a dot at 2, 3, and I could go 4 to the right, 1, 2, 3, 4. That's obviously going to be 4. I could go 6 down, 1, 2, 3, 4, 5, 6. That's going to be 6. Is that not the same thing? Yes or no? Yes. So don't get caught up in plotting the point and all that. These will be your side links of a right triangle. Everybody good? All right. The side across from the right angle is the C. So am I adding or subtracting? So I'm doing the square root of, and I'm going to add those. 4 squared plus 6 squared. And I'm at 7.2, so which one is the closest? Which one? 7. Number 11. And then we're finished, yes? The coordinates of the vertices of the triangle shown are, and it gives them to you. Did I even need all that? No, I have a picture, and I can count how far this is down. Now, of course, it's going to look better than this. I mean, because the lines didn't show up just because of the copy machine, so I'm just showing them to you. So I can count these units. This is 1, 2, 3, 4, 5, 6, 7, 8. Can I count these? Yes. So this is a line, a line, a line, a line, a line. Okay. 1, 2, 3, 4, 5, 6. Can I count these? No, because they're diagonal. You just can't do it. But I can use Pythagorean theorem to solve for the missing side. So am I going to add or subtract? Add. Okay, so I'm going to do the square root of 8 squared plus 6 squared. If you want to see it, it looks like this. So I have 8 squared plus 6 squared equals c squared. So I would add those. You would get 100. And then you would square root it. So it's the same thing. And your answer is 10. If I had to put that on a griddable, everybody look. If I had to put this on a griddable, and the decimal's right here, where would the 10 have to go? Before the decimal. If I put it here, this is like saying 10 whole dollars. If I put it back here, that's like saying 10 cents. And you don't ever put it back there unless you see the decimal in your answer, correct? All right, you have the rest of class, which is only 5 minutes, to log into the Google Classroom and get these answers put in.